So what I'd like to do with this video is run through a lot of the function analysis questions. We analyze this function according to various different criteria in calculus. So this is a f of x is x squared times 3 minus x. They ask you to find absolute extreme values on this interval, 0 to 3, this interval from -1 to 4. Find out where that function is increasing and decreasing. Find local extremes, whereas f concave up or down. Find the inflection points, go with it, and then sketch the graph at the end. So let's run top to bottom here, working through this. This very well could be split into multiple videos, but we'll do it all in one go here. The absolute extreme values on this interval from 0 to 3. So we're looking for absolute extreme values on a closed interval. And when you're doing that, what you need to be looking for is critical numbers. Those are places where f prime of x is 0, or f prime of x is undefined. And this is the one that students often forget, looking for where it's undefined. It's not such a big deal for polynomials because it doesn't happen, but if there's radicals in there, if there is any division happening, this is definitely a case that's the time that might happen. It won't happen for this one, though. You're also going to want to be checking the endpoints. Those are the only places where the extreme values might happen, the only x values that make the derivative 0 or undefined, or x values that are the ends, the 0 and the 3, or the -1 and the 4, depending on which of the intervals we're interested in. You do the endpoints right away. You don't have to do any math for that. Well, you do calculations, but you don't have to do any real algebra. F of 0 is our function. Go to your original function. 0 squared times 3 minus 0, 0. F of 3 is 3 squared times 3 minus 3. That's also 0. And so maybe 0 is an absolute extreme value, maybe not, but it definitely goes on the candidate list. As far as critical numbers, we're going to need f prime. F prime of x equals, well, remember how f of x is written. You could do product rule, split this all up. It's probably easier to distribute first and just do a couple power rules instead. So that's 3x squared, so the derivative of that is 6x. X cubed, derivative of that is 3x squared. I want to find out where that is 0, because that's definitely never undefined. I'd like to write that just to show that I thought about it. It's never undefined. Factor out the 3 and an x, and so I get 2 minus x equals 0. So either x equals 0 or x equals 2. Those are our critical numbers. Critical numbers. Some books really draw a distinction between critical numbers and critical values. Stewart, for example, only ever uses the word numbers for inputs and uses values for outputs. So these are inputs, 0 and 2. Yeah, there's some redundancy between endpoints and critical numbers. That happens sometimes. There's overlap. Not a big deal. So we're going to need to find f of 0, which we already did because it was a endpoint. We're going to find f of 2, which is 2 squared times 3 minus 2, or I could have plugged it into the 3 times 2 squared minus 2 cubed, but I'd rather do this calculation for this when I'm plugging in. That's 4 times 1. That's 4. And so what we're looking to compare is 0, 0, 0, and 4. Which one's biggest, which one's smallest? Not too hard to figure out. Absolute minimum is 0, and the absolute maximum is 4. Remember, it's the y values. And that 0 happens at x equals 0, and x equals 3, and the absolute maximum is happening at x equals 2. Also, some books talk about the absolute minimum value versus the absolute minimum. Stewart talked about absolute minimum value, and they're talking about y values only. All right, so that's part A there. The only real difference for part B, do A but for the interval from -1 to 4, is just the endpoints are different. The critical numbers are the same. Those are really based on the function. The endpoints are based on the interval you're given. And for what it's worth, this doesn't happen here, but it's entirely possible these critical numbers 0 and 2 lie outside the interval they're asking about. It doesn't happen here, but it could. You don't look at that critical number anymore. It's off stage. You're not interested. So for part B there, we've already done most of the work, but we're looking for absolute, the absolute extremes on the interval from -1 to 4. We already know that our critical numbers are 0 and 2 from 2 minutes ago. Are 0 and 2. Our endpoints are -1 and 4 from the given interval. So we got to go finding f of -1, f of 0, f of 2, and f of 4. We already found f of 0 was 0. In the previous problem, we already found f of 2 was 4 in our original problem. F of 4, that's 4 squared. 3 minus 4, that works out to be -16. Well, that's definitely a new low. F of -1 squared times 3 minus -1. That works out to be 4. It's the tie for biggest. You can have ties, that's fine. There's a less than or equal to as part of the definition for absolute maximum. And so our absolute max is 4. Our absolute min is -16. You know, 4 is happening at 2 and at -1. Our -16 is happening at the endpoint of 4. At this point, we have somewhat of an idea of what this looks like, just from plotting all these points that we've gathered. Weird stuff may happen that this is missed, but still, if that's 2, we know what happens at 2, at 3, at 4. We don't really know what happens at 1. We know what happens at -1. At -1, the height is 4. At 0, the height is 0. At 3, the height is 0 from all those calculations. F of 2, we said, was 4. And f of 4 was -16, way down below. And so it looks something like that. It goes down, up, down. This is we can only draw this confidently because we know these are critical numbers, these values. If we had f of 1, for example, but not f of 2, we wouldn't know where the turnaround happens. We wouldn't know if it happens somewhere between 1 and 2, between 2 and 3, or wherever. But because we know these are critical numbers, we know the turnarounds are going to be happening there, and are not going to happen anywhere else in particular. All right. But anyway, that's finding absolute extremes on a closed interval.